Gentlemen, I, Dr. Arun Prakash Agrawal, welcome you all on behalf of Sharda University. I would also like to welcome our guest and speaker today, Dr. P.S. Rana from Thapar Institute of Engineering and Technology, Patiala. My dear friends, Sharda University is a leading educational institution, a venture of the renowned Sharda Group of institutions. The university is approved by UGC and feels pride in being the only multidisciplinary campus in the NCR. Spread over 63 acres lush green campus equipped with world-class facilities. University offers around 216 different courses at undergraduate and postgraduate levels, including PhD in various domains. We have students from over 85 plus countries other than India and has thus become a melting pot of diverse cultures, backgrounds, and ethnicities. This is the second last day of this international FDP, which is themed on recent advances in computer science and allied domains. We are really very happy to see the feedbacks submitted by the participants after attending sessions in the last 4 days. I now take this opportunity to introduce our guest and speaker to the audience, Dr. P.S. Rana. Dr. Prashant Singh Rana is presently working as an assistant professor in Computer Science and Engineering Department with Thapar Institute of Engineering and Technology, Patiala, Punjab. He received his master's as well as PhD in computer science from a reputed and well-known ABV IIITM Gwalior. His areas of research include machine learning, deep learning, bioinformatics, and optimization. He has published more than 70 research articles in different journals and conferences of repute. He has completed 3 sponsored projects, in which 2 projects were sponsored by DST Serb, and 2 of his projects are still going on. He has also filed 9 patents. He has guided 7 PhDs and 18 master's students. Today, he is going to share his views on data generation using modeling and simulation for machine learning and hands-on practice on PyCrat. With this, may I now request Dr. Rana to kindly take over and address the audience. Over to you, sir. Ankur sir, please allow Dr. P.S. Rana to unmute himself.
Okay, Arun sir, thank you very much.
Welcome,
And
sir.
Good afternoon, all the participants. So, Arun sir, start kare?
Yes, sir. Please go ahead.
Okay. So welcome to the current session that is on data generation using modeling and simulation for machine learning. So, in this session, we are going to cover the basic concept ki how to generate data for machine learning. And in the second phase, we are going to cover some how to build machine learning quickly using a Python library known as PyCaret. So before starting, I want to know what is the difference between machine learning and deep learning. So in the last 3 days or 4 days, you are learning what about the deep learning. So the basic difference is that in the machine learning, we need to extract the features. Let's suppose we are building a machine learning model for classifying the object that is car or not car. So we need to extract the feature manually. After that, we need to build a machine learning model, and that model will able to predict if the object is car or not car. Okay, that is a basic concept about machine learning. But in the deep learning, the feature extraction and model building are clubbed together. So let's suppose take an example of car and non-car. Means you must have 2 folders that contain one folder as car and another folder as not car. Just build the model, and that model will able to predict if it is a car or not car. So if somebody asks what is the difference between machine learning and deep learning, so that is the basic difference. Now, before starting, let me introduce some concept about machine learning. See what is a structured, semi-structured, and unstructured data. So take an example for the unstructured data set. There is no format defined for the defined. So that is considered as unstructured data. So example are, let's suppose you have 1,000 movies stored in a folder. Okay, 1,000 dogs in a folder, 500 images in a folder. So it is just a dump that is not organized. So you can say that this is an unstructured data. Now, next is structured data. In the structured data, it is stored in a well-defined format. So well-defined format means, let's take an example of song. So I have a folder that contains 500 songs, and there is a song ID. I store its language, what is the genre, it is a what is the number of singers, likes and dislikes. So these are the some common features that I extracted for the song. There can be many other features you can extract about the about its in different languages. So this is the well defined format to store the data. So that is the basic concept about how structured data look like. Next, semi-structured data. So in the semi-structured data, very little format is defined. Means, let's suppose you have a folder, you have 1,000 movie, and they are stored in 3 folders. Means 12 plus, 16 plus, 18 plus, and somewhat little information is provided. Let's suppose there are 10,000 documents that are stored in different categories. Category means A, B, C, D. Next, 500 photos are stored in 2 folders, means male and female. So that is a very little information about the data set. Okay, so that is known as semi-structured data. Now, for the machine learning, the data format required is like this. We have some number of columns. Okay, let's suppose x1 and x till x5 are my input variable known as independent variable, and one column is defined as a target column. Okay, so that column is known as target column. So that is the input. So hope everybody know about it. It contains some input and only one output. Next. Now the biggest issue or hurdle or problem with the machine learning is that the availability of structured data. Presently, large amount of data set is generated, but they are not classified, they are not stored in a well-defined format. Take an example, you are uploading a video. Okay, you are not labeled that video. You are storing your images that is not unlabeled. So we all are generating or storing a data in an unstructured manner. Okay. So now the solution is that we can generate the data using modeling and simulations. So simulations, everybody knows what simulation is. It is an executing a real world process in a control environment. Okay, so simulation everybody knows. So the topic for today's talk is how to generate the data using simulation for the machine learning. So take an example. This is the dam. Okay, so now let's suppose we want to generate a simulation for breaking a dam, but it is not allowed in a real form, in a real world problem. Nobody is allowed to break the dam, but in a simulation environment you can change its different parameters, means volume of the water, quantity of the water, number of gates, concrete used in the construction of the building, in construction of the wall. So there are different parameters you can change. Now you can execute what is the strength of the dam. Okay, now so these are the following parameters that are required for the dam: height of the wall, width of the wall, what is the quantity of the water, quality of concrete used, water flow, number of gates, and lot of other parameter we can extract. So next example is car crash. Let's suppose Tata Motors declare its car is most safe in the world. So to prove that concept, how many cars they can use for the crash? 2, 3, 4, maximum 4 up to. Because the car costs nearly 10 lakh rupees. So it is not possible to make 10 or 100 or 1,000 simulations, 1,000 crash. But in a simulation environment, we can perform n number of crashes. So this is one example. Next, chemical reaction. Let's suppose in class 11th and 12th, you perform lot of chemical reaction in your classes. So you perform all the experiment in at the room temperature and the room pressure. But let's suppose I'm saying you need to perform a experiment at -40 degree. So that is not possible. Okay, but in a simulation environment, we can perform that. So what is this? Anyone? Audience, please. You can write in the
Participants,
chat.
yeah, participants, you can write your answer in the chat window.
Okay.
Two responses, sir. Bulletproof jacket testing.
Very good, very good. Perfect, perfect, perfect. Bulletproof testing. So this is a testing of a bulletproof jacket. A man is shooting a person who is wearing a bulletproof jacket. Now, but the cost for a one jacket is 2 lakh rupees. So let's suppose you are going to test कि हाँ ये it is worthful or not. So you cannot make more than 2 or 3 or 4 tested. But one more thing, if you shoot a bulletproof jacket, you cannot you cannot reuse it. It means if you shoot one bullet, so 2 lakh rupees you're gone. Okay. So in the real example, real scenarios, we cannot perform more tested. But in the simulation environment, we can perform n number of tests. Okay. Now, if you go to the Google, if you search for list of computer simulation softwares, so you will find a wiki page that consists of long list of simulation softwares that belong to free and open source, also proprietary softwares. So that there are different domains in which you can find easily find the simulation softwares. Now, so these are the particular domains where you can find the simulations like molecular dynamics, astronomy, chemical kinetics, 2D physics simulator, scientific prototyping, network simulator, blah, 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 medical simulation, transportation, and environmental planning. Now, why I am focusing on these topics? Because nowadays, all our research, it is of machine learning or a deep learning, are concentrating only on the few topics: image processing, video processing, object detection. Okay, so these are NLP. So these are the only few topics where all our 90% research are only focusing on only these 5 or 6 topics. So there are a lot of other domains we can perform or apply machine learning or deep learning. Okay. Next, so take an example of DAM. How exactly we are going to generate the data set. So let's suppose DAM, there is a library I find in the Python or MATLAB or any other language. So just install the library, import it. So sim, there is a function with the name sim in the DAM library. So that input 5 parameters. Okay. Now these are the 5 parameters. Now these parameter can be anything like height of a wall, concrete quality, number of gates, and every parameters having a lower bound and upper bound. Okay. So these are the 5 inputs. Now I generate a random set of parameter from x1 to x5, pass to this simulation software function. It will execute. It will take some time. Let's suppose 5 to 10 minutes. After simulation, it returns a strength, and I note it down in this column. So this is the first entry that I generated. So similarly, generate another set of variable, pass to the function, simulate it. You will get the strength and note it down. So this is the way you can generate up to 1,000, 10,000 number of data sets. Okay. So now this is my regression data set. Okay. Now regression data set, everybody knows if the target column is of real type values, then that data set is considered as a regression data set. If target column is of discrete values, then that considered as a classification data set. Okay. Now when I play with this library, I found one interesting thing is that if the strength value is greater than or equal to 25, then the DAM is stable. Okay. So I put all the value that is equal to or greater than 25, I put at 1, and less than 24, less than 25, I put at 0. Means I am transforming my regression data to the binary classification data. So one important learning for you is that if you have a regression data set, then you can produce 2 research papers. Number one, applying regression models, and when you transform the data into binary classification, you can produce another paper. So that is very important thing for you. If you are able to generate, if you are able to get the regression data set. So and then there is a possibility you can produce two papers. Okay. Next, so this is the example of Cantera. Cantera is a chemical kinetic package that simulates the chemical reactions. So let's suppose this is a chemical reaction I want to perform and under different temperature and pressure. And this is a rate of reaction that I want to execute. Okay. So now for the temperature, I consider minus 40 and 40. For the pressure, 10 and 50 is there. So this is a library available in Python. One of my PhD student, one of my master students work in this domain. Okay, thus import the library. After that, there is a function with the name Cantera. It took two parameters, temperature and pressure, and that returns the rate of reaction. Okay, so now generate a random set of temperature and pressure, pass to the function, it will simulate, and it return you a value. That is rate. I write it down here. Again, generate another parameter, note it down. So similarly, you can generate let's suppose 1,000 or 10,000 data set. Okay. Then after that, you need to build a model. That model will able to predict the rate of reaction when you provide temperature and pressure. Okay. So that is a basic concept. Whenever you generate the data set, you need to prepare a model. Now, next example, that is a very interesting one, OpenSim. So OpenSim is a open source library for biomechanical modeling. Let's suppose I want to simulate a walking of a person or sitting of a person or moving my neck, moving my shoulder, moving my hand or a walking. So this software will help you a lot. Now, let's suppose I want to simulate, I want to generate a prosthetic leg or a walking assistive devices for the walking for my old age people. Okay, so let's suppose I want to simulate a person is walking. Now there are four parameters: height, weight, age, and speed. And every parameter have some lower bound and upper bound. Okay, now just import the library. So this is the OpenSim function that required four parameters. Okay, and that produce four forces. So these four forces help to move a person. Okay. Now generate a random set of parameters, pass to this function. Let's suppose age is 50, height is 102, weight is 68, and speed is 4. Okay, generate a set. It will simulate. It will take time. Let's suppose 30 minutes. Then after 30 minutes simulation, it will generate four forces. So these forces will help a person to move at a speed of 4 kilometers per hour. Okay. Similarly, generate another set. You will get four forces again. So similarly, you can execute it for 1,000 or 2,000 or 10,000 times. So you get this data set. But one important thing is that there are four outputs. Means you need to generate four machine learning models for the prediction of every force independently. Okay. So you need to create a model for F1, F2, F3, F4, but all the four parameters will be same for all finding all the parameters, all the forces. Done. Now, these four models will help you to find a person. Let's suppose a new person will come. You need to find his age, height, weight, and speed. So these four inputs give to the model independently. All the four model will able to predict what are the different forces required for that person to move at that particular speed. Okay, so that is the basic advantage of machine learning model. Next, so I hope you everybody understand. Please write in a chat yes or no, or if you have any question query, you may write in the chat also. Okay, very good. Now, one more important question asked by Ravinder: how to decide the threshold value for converting regression data to classification data? Very good question, Ravinder. Basically, when you play with the library, so there are several manuals and literature, and you may also find some papers that cite this software, this library or package. Then you need to study them. Okay, this value can be 26, this value can be 28 also. ठीक है. So after going to the literature survey, you can able to find the lower bound and upper bound for every parameter. Okay. Next. So class, this is one of the case study. This is one of the research paper published by my BTech student. So audio genre classification. So we need to find out the what is a genre for a particular audio, and for this he uses GT-Zen audio dataset that consists of 696 audio files, and this 696 audio files are classified in 5 genre, means that is a semi-structured data. Okay, means I have five folders, and every folder contains some number of files. Okay, and the total number of audio files are 696. Now there is a Python library with the name Librosa. So we use this Librosa library to extract the features. So there are total 193 features, and that are categorized into five different subclasses. Means MFCC contain 40 parameters, Chroma contain 12 parameters, similarly MEL contain 128 parameters. So total there are 196 parameters. So means this is the final data set that we created. We pass each and every audio file to the Librosa library, and that gives us 193 features. So we note it down. Again, we label according to their folder. So pop is there, classical is there, rock is there, metal is there, hip hop is there. So that is a sample data set that we created. Now, this is a multi-class classification. So we apply multi-classification model and we write the paper. Okay, so that is the basic concept of machine learning. Now the big question is that, please listen carefully, if simulator is available, then why to generate data and use machine learning? Okay, because both the machine learning model and simulator do the same thing. They need some input parameter and they give you the one output. Okay, now answer is that simulation took huge time. Okay, a single simulation can take up to 1 hour, 12 hour, 1 day, 10 days. So there are lot of time are required to execute a single statement, single simulation. Now let me explain with this example. Let's suppose this man of age 50, height 102, weight 68. It's run for 1 kilometer. Okay, now he got tired. Now he want to reduce his speed from 4 to 2 km per hour. Okay, now he want to slow down his speed. So if he want to slow down his speed, then these are the new forces are required. Okay, so means a person is standing 4 km, it pass new parameter to this parameter, this function. It's wait for 1 hour, then he will get the new forces, and then he start the walking again. So waiting for a 1 hour time is not feasible. But if you pass these new parameter to the machine learning model, you will get the new forces parameter almost in a real time. Are you getting? So this is the most important thing, why generating a data set using simulation and modeling for machine learning, why it is helpful. Because predicting a new forces through machine learning model, it is a just matter of time. You can almost predict in a real time environment. So that is the most important thing about why we use simulations. So I hope everybody is getting. So if you have any question, query, you may write in the chat. Okay, so one question is asked by Tejasvi. Based on 193 feature, genre was generated. No, genre was already known to us. Genre was already known to us because 169 files are stored in 5 folders. So there are let's suppose first is rock. So there might be a possibility that 100 audio files are stored in a rock folder. There might be possibility pop. So some audio are stored in a pop folder. So 5 folders are there and total 696 audio files are there. So I pass each and every file to the Librosa library and I created this data set. Okay, I hope everybody is understanding this. Please write in the chat, yeah. Yes or no? Are you getting?
Participants, please keep writing your response in the chat window so that the speaker is aware that you are understanding the concept or not. It
Okay,
will
very
help
nice.
him a lot.
Thanks, thanks. Because interaction is zaruri hai. So now, next topic. So, basic idea for data generation. So class, this is a very basic idea how to generate a data set. Very first important thing is find your domain, in which domain you are working. Right now, I am working in fluid dynamics. Okay, so that fluid dynamics I am working on. So I working with different packages, I explore it, I start working, I install it and play with it. Okay, so now my next research is focus on applying machine learning in fluid dynamics. So now find a suitable tool, software, library or package of your interest, install it, and go through with its manual or some working example and play with it. After that, you need to find out the parameter. That parameter you need to explore. Okay, how many number of functions, how many number of parameter are required for the function. That is the most important thing. Okay. Now after that, generate a random set of parameter, pass to the function or simulator, and record the value. Okay. So that is a basic concept about generating a data set for the machine learning. Next, random parameter generation. So let's suppose there is a wide variety of, let's suppose this is a function, x1, 4 parameter are there, x1, x2, x3, x4, and every parameter has some lower bound and upper bound. Okay. So now if I'm saying generate 100 rows and save to a file, and it means I want this type of output. So that is a Python code. So that is you can write in any language, but this Python is a very simple one. So I just write in the Python code. So import a random R. I store, say I open a file in writing mode. I also already write x1, x2, x3, x4. Now run a loop for 100 times. Calculate the, there is a function with the name randint. So it will generate a random number between 10 and 100. Store in x1, x2, x3, x4. Similarly, you store all the parameter in a s variable and write to a file. So this loop will execute for 100 times, and it will generate random parameters and store in a file. After that, you need to close, and all the content are written in the file. So that is a basic concept. Next, objective function. So class, objective function is nothing but just a function that took some parameter, okay, and that returns some or multiple single or multiple value. Okay, now it's our requirement or our objective to make it maximize or minimize. Okay, so now take an example. Let's suppose sim function is there. So it take 5 parameters, it performs some simulation, and it may return some value. Okay, take an example. So that is a mathematical formulation for this function, the mathematical formulation for the function. So that is a summation of absolute value of x of I, and that is a multiplication of x of I. Now if uh, i I want to code this function, then how we are going to do that? So define a function with the name fitness function. So class, this is a code in Python. So def is a keyword. We need to find, we need to write a function, fitness function, with the variable x. X is a list. So we need to store sum and product. So for storing the sum, I make it 0, and the product, I make it 1. So I running a to loop for making its summation. So I make absolute. So this will store all the summation, and this will store all the product, and I return s plus p. Okay, so I can also optimize this code. I run both the loop in a single. Calculate both the variables in a single loop. So this is the way I can write. So simply s plus p is my outcome. Okay, so this is a basic concept about fitness function. Now, if I pass 4 parameters, 4 set of variable for the x, let's suppose c1, c2, c3, c4 are there, and I just call the function with the name fitness function, and I pass these list, it will execute and give me the result. Okay, So that is a basic concept how to call a fitness function. Now, similarly, you can write the code for this variable also. So there are only two variables, x1 and x2. So you can easily write the function like this. So this is the same way we write it earlier form. Now, let's suppose we want to generate, these are the parameters, x from x1 to x8. Now we want to simulate this. Okay. So first, this is a function. We want to add all the variables. Okay. So I write a function, fitness function like this, fitness function x. X is a list that contain number of variables, and I return it sum. Okay. So that is the code for fitness function for this variable, this expression. Next, this is class quite interesting, and listen carefully. So first, I open a file in the writing mode. Okay, I already write some string that will be the column name in the file. I run a loop for 100 times. I calculate the variables of in the within the lower bound and upper bound. After that, I pass to the fitness function and get the target value. Okay, so I store all the variables including target to a string variable s and write to the file. So similarly, this loop will run for 100 times, generate the some random samples and find out the target value and close this. So after running that code, we are able to get this type of data set. So that is the basic requirement for data set for the machine learning. Okay, so that is the 8 features are there, and this is a target. So this is your regression variable, regression data set. So we can generate this data set. After that, we can apply some machine learning models. We may apply ensemble technique. We may apply feature selection. We may apply outlier removal. So these are the other parameters, that other operations that you need to apply. But the concept is that how to generate for a data set for the different domain. Okay. Now, so take an example for the OpenSim. I import the function OpenSim. I created a function with the name fitness function. I pass the variable. Now there is a function with the name sim available in the OpenSim. So I dot sim pass the function, pass the list. It will take 10 to 15 minutes and give you the force values, and then you need to return that. Means you need to write the function in a fitness function. So that is a user defined function, and we are we writing the code in a fitness function. Okay. Now take an example, case number 2. So this is the most important thing. Some simulations will not give you the direct value. If you perform some simulation that will not give you the direct value, they store the result in a file. Okay, now we need to extract the result value from the file. Okay, now take an example. I import OpenSim. I define a fitness function. I run the simulations. So the result file, result or a force are saved in a force file. Okay, now we need to read that file, extract the particular line. So that is my value of interest. Return that value. Okay, so that is one more important thing. The simulation result, if simulation are storing the result in a file, then we need to read the file and extract the values. Now second, this is the same thing as OpenSim. We run the Cantera, we run the simulation, and we store in a rate of reaction. Okay, so these are the 3 things we need to get the value from the simulations. Now next important thing, how to call the external commands. So that is not a part of this talk, but let me introduce you how to call a different uh, commands through different programming languages. So let's suppose if you are working in Python, you need to open a calculator. So there is a library with the name import os.system, then pass the calc. So it will just pop up the calculator. If you write the notepad, it will open a notepad for you. If you write MS Paint, it will open a paint program for you. Now you can also run a Python program from a Python file. So you need to write Python and random.py. So let's suppose this is my one of the program of written in Python. So I can write os.system, Python and Python. Similarly, another program written in Python, ga.py. Now, if you run your R program, so R is one of the programming language similar to MATLAB and Python, then you need to write like this, R script and name of the file name. So by using Python, you can call the program of R. Okay, now let's suppose if you are working in R is another programming language. So there is no need to import any library. There is a with the same name function system. So you need to directly call the command. Okay. Similarly, if you are working with MATLAB or Octave, all the commands will use similarly. So function system function is there. Okay. So I think for the C++, I am not confirm for the Java, but all the system functions are same in all the languages that can be used to call a different program in written in different languages. Okay. So now take an example. This is one of the pipeline. This is a task. Let's suppose we need to download 100 images of bike from Google Images. Okay, resize all the images to 50%. You need to reduce. After that, convert all the images to grayscale, zip all the files and mail to the email ID. So class, this is a list of tasks you need to perform, and every operation have a different program. Okay, so take an example. This is the uh, random sample file for you. So let's suppose I write a program that download Google Images. A Python program is there. So this is your automate.py. This is your main program, and there are different other programs that you already write to download the images. You write a MATLAB program to resize them. Again, you write a program for converting a grayscale. Okay, you write a Java program to zip all the files in a single file. Again, you write a program to zip file to the user. Okay, so this is the automate library you can also create. Okay, so this is the graphical representation for the same program that we executed earlier. So that is not the part. So I think this is the main concept about data generation using modeling and simulation. So hope you understand how to generate the data. So if you have any question, you may ask in the chat. So are you getting anything?
Sir, one question is there
Yes.
from Aditya Kumar. Is
OpenCV.
OpenSIM and OpenCV similar open source tools?
No. OpenCV is a library for image processing. Okay, and OpenSIM is a biomechanical software that simulates the different biomechanics. Means I need to my shoulder, I need to my wrist, I want to simulate my for the neck. So that is a different library. So any other question?
Participants, if you have any other question, you can write in the chat window. I can read it for you.
Okay, okay. So let's move forward. Now use of PyCaret. So just give me 1 minute. Let me switch my window.
Definitely, sir. Take your time.
Okay. So font size is okay.
Yeah, it's perfectly right, sir.
Okay. So now class, welcome to the next session. That is PyCaret for regression. So I already shared these resources with you in the link. So there are three libraries, three notebook files are there, and the same slide that I presented just earlier, that it is also stored over there. So now how to create our regression model quickly, okay, without writing much more code. Okay, So just focus here. So these are some learning resources you can learn yourself. I've also provided the link. So you need to open this file in a Jupyter notebook. This file will not open directly in a notepad or a web browser. You need to learn how to open in a Jupyter notebook. Okay, so that is a notebook are there. So if you open the file, so very first step, you need to install the PyCaret. So I also mentioned some help file is there, okay, how to install the PyCaret package. Okay, so there are two methods. There is also a manual is available, so you can also follow the manual. Now, class, if you double click here, so this is the concept in the notebook. You need to just press Control Enter. It will display in a HTML format also there. Next, so these are the following uh, terms and topics that we are going to cover today in this session. So I hope everybody knows what regression is.
Guys, you can write your answers in the chat box. We are receiving positive responses, sir. Yes, yes.
Okay, no issues. So everybody knows what regression is. So they are the most important thing about PyCaret library is that it is an open source and automated library for machine learning. Okay, there are only 3 steps to build and compare all the models for classification, regression, and clustering. Okay, so now I'm showing you just a demo. So I already write and executed the code for you so that we can save the time. But if you want to execute the code, you need to press Control Enter. If you find this type, like this is a gray window. So if you press Control Enter, it will execute. Okay, because time is limited, so I already executed the code. So very first is data loading. Okay, so I import the library PyCaret utils import version. So I'm using a PyCaret version is 2.2.1. Okay, so I'm requesting all of you, if you have version 2.2.1, this is the latest version I just installed 2 days back. So that is a upgraded version for PyCaret. Next is loading the data set from PyCaret. So there are some data set that are already available in the PyCaret package. So internet connection must be there. So PyCaret.datasets import get data. So we are importing a get data functions that will automatically load the dataset for you. Okay. So now I run get data.index. I pass the function. I pass a parameter index that will show you some data sets. So after executing this function, you will find there are nearly 55 data sets are available. Now this is the categorization, means this data set is for regression, this data set for clustering, NLP, classification. Okay, so these are the classification clustering. So you will find 55 data set, and this is the basic data metadata available for the data set, means target, which is the target column, number of instances, number of attributes, is missing values there or not. Okay. Aditya, basically, just 2.2.1 version is released 2 days back, 2 or 3 days back. Now, next step, we are working in regression data set. So there is a data set with the name Boston. Now, where Boston is that? So you need to write this name only. First name, data set name. So we are working with the name Boston, and this is at the number 46. Okay, so if you want to work on a bike, so you need to just pass bike. Okay, so now get data set, this is a function, and I read the data set in the Boston df. So that is a data set, and in this data set, target column is last one, MEDV, and you easily find the value is of decimal values, Continuous values are there, so that's why it is a regression data set. Okay, so now we are going to build multiple models on this data set. That is the objective for this hands-on workshop. So now there is a function with the name dot shape. So it will return the number of columns and number of row present for the data set. So there are 506 rows and 14 columns are there. Okay, so very first step, if you work on any data set, first remove the duplicate values. So to remove the duplicates, there is a function with the name dot drop duplicates. So Boston df drop duplicates. Okay, it will automatically drop the duplicate values. Now class, let's suppose if you want to work with your own data set. So क्या करने का? You need to do that. You need to read your data set here. Okay, so there is a library in the pandas pd.read.csv. So you can easily read your data set so that nothing can be changed, nothing, no need to change in this code. It will run automatically. Okay, so in the data set, you need to just read your data set. Next, so this is the very first step. Here we just read the data. Step number 1. Now in the next step, there is a library with the py_regression. Okay, so we import the regression and we import all the functions available in the regression library. Okay, so there is a function with the name setup. So class, if you click over here and if you pass shift tab, in the shift tab you will find a small help is there. So this is the help for the setup function. What are the different functions? What are the different parameters are there? And if you scroll down, you will find all the parameters and all the help there. Okay, so there is a function with the name setup. Very first parameter is data. Okay, on which data set we want to use. Next, target column. Okay, so in the target column, we need to define which column is our target. So our target is MDEV. So just see the data set. So this is my last column, MEDV. If I have a column, my target column is crime. Okay, so I use crime. Okay, next. So if you run the code, so this parameter will set and it will ask you to change the, it will ask for something, just press enter. Okay, so these are the parameters it uses for the simulations, for the execution. Now, so that is the second step. We set up the parameter for all the machine learning models. Now, third step is compare models. So basically, py runs nearly 15, 16 regression models for you. Now, if you run this code 1.3, it will run for you. So let me run for you again. So now it is running all the models one by one. And for the regression, you know very well, it divide the data set into two parts, 70 and 30. Okay, 70% data is for regression training and remaining 30% for the testing. Okay, so now it is compare nearly 15, 16 machine learning models on different parameters like mean absolute error, mean square error, root mean square error, R square. Okay, so these are some parameters, just a matrix. So I think it is done. Yes. Now in the top, you will find ET is the topmost performer because its R square is maximum. No, now it is, yes. So after running the comparing all the calling compare function, compare models, it will give you comparison of all the machine learning models. So now there is no need to write the individual code for each model. So that is a bundle of multiple models. Now in the backend, this PyCaret package uses scikit-learn library for all these available models, compare and return you this table. Because in the research paper, we need to present this comparison for the machine learning models. Agree? Yes. So this is only 3-step process to compare and build machine learning models. Now next. So let's suppose we want, now in this example, our cat boost model. ठीक है. Now let's compare how to run an individual model. ठीक है. So there is a function, there is a model with the name cat boost. Okay, so now we will run this model. Now if you want to run a single model, then create function, create model is a function. You need to pass the name of the model. Okay, it will create a model. Now I want to plot a residual plot. So residual plot, just plot model. This is the building model over there, and you need to pass residual. So that is a residual pair that shows the R square value of the model. This is for training set and this is for testing set. Okay. Next is scatter plot. So plot model, this is at my train model. We just need to pass the parameter as error. It will plot the scatter plot. Okay. It will also show you the R square value. Next, learning curve. Now these all plots will help you to plot in use in your research papers, so that you can just present what is the learning rate. Okay, what is the validation curve. Now I just make it the comment in the learning curve because it will take nearly 5 minutes for the execution. Now if you got this notebook, you can run in your machine, because my machine took nearly 5 minutes. Okay, so you will plot the validation curve. So validation curve is similar to k-fold validation. It will run for 10 times, and that will show you if there is a gap in the there is a lower down in the zigzag in the performance. So that model will not be able to work very well. Okay, so class, are you getting till here? Okay. Okay, nice. So now that is a basic part about PyCaret. Okay, without running, without putting more effort, we are able to get the comparison of multiple models on my data set. Nowadays, running a model is not a big deal. Nowadays, domain knowledge of the data set is important, because the same subject and the same notebook I am using to train my second year students, my second year BTech students. So all the things they know very well. So I train my students to generate the data set for the different domains. Okay, because nowadays machine learning is just a methodology part, but the domain part is very important. How we are extracting the data set, how to build a model is not a rocket science. Okay, now next part is model performance using different techniques. Let's suppose there is a function with the name setup. I want to apply data normalization. Okay, so now for normalization, you need to just pass normalize equal to true and normalize method. Now class, if you click in the setup function, and if you press shift tab, a help window will open. Now here you will find that this time I am using normalization equal to true. So by default, it is false. Yes, normalize equal to false. And if I make it true, then by which default normalization method will use is z-score. Okay. Now, if you go to the end, you will find there are different other method you can use for normalization. Okay. So now we are just checking the performance after normalization. Okay, which model is performed better. Okay. So let's run the code. I already run for you. So by default is normalization. We are using z-score. You can also use min max, max absolute, or robust. So if I run the code with the normalization, and okay, what is the effect of normalization? What is the effect on performance of the model after applying normalization? So you will find GBR model is outperformed. Its R square value is 0.85. Okay, and cat boost is come to 0.3rd position. But the R square value is not much differ in the values. So all the 3 or 4 models perform almost at the same pace. Next, feature selection. This is an important concept in machine learning. Let's suppose you have 100 features and you want to find out how many number of features, minimum features are required to build the model with the same accuracy. Because let's suppose you are building a model with the 100 features and you are building the same model with the 10 features, and definitely you will get an improvement in execution time and in prediction time. Okay, so what is the effect of feature selections? So feature selection, I make it feature selection true, and the by default feature selection technique used here is a Pearson correlation. Means let's suppose there are two features that Pearson correlation is greater than 0.8, then we need to drop that. Because if the correlation of two variables is greater than or equal to zero point 0.8 or 0.85 or zero point 0.9, then both the features are same. So using the same features will not improve the performance of the model. So we need to drop it. So here we are using a threshold 0.8. You can change this threshold also. Okay. So whenever I use threshold 0.8, so that is the performance of the regression model. So for the ET outperform, that gives the R square value is 0.86. So class, are you getting anything till now? Please write your response in the chat.
So there was one question from Mr. Ravinder. Yeah, it was like how to use cross validation technique, 10-fold cross validation with PyCaret. And in continuation to this, he is interested in knowing that instead of using 70-30 train test data, how to use cross validation technique.
I will cover this concept in the next part, third part, where I'm building a same model. I'm building a single model, so we can define over there how many cross validation we are required. So just wait for 5 minutes. I'm covering that part in the next part.
Yeah.
So now come to 2.3. Now model performance using outlier removal. Everybody knows what outlier is. So if I want to use outlier in my model building, so make outlier, remove outlier equal to true. Okay. Now you need to also define the threshold for the outlier, because in the outlier we are using a bell-shaped curve. So 0.5 means in the extreme left values and extreme right values we are removing, and 5% from the left, 5% from the right. Okay. You can also change this threshold value. Okay. So what is the effect of removing outliers? You will see ET is the model that outperform, and also its R square values also increases. It comes to 0.87. Okay. Next, performance of transformation. So class, transformation means, let's suppose there is a column, its values consist from 1 to 100. Okay. That value is varying from 1 to 100. And I am saying that if the value is between 1 and 10, use 5. Okay. If values from 11 to 20, use 15. Means I label them a single value for a range of values. So that is one of the example of transformation. There are different transformation also available. Like I consider in the DAM, if the value is less than greater than 20 or 25, reported 1, less than 25, reported at 0. So that is one of the transformation. Okay. So there are different transformation. So by default method is Yeo Johnson. It is one of the transformation. So let's suppose that let's run the code for transformation. So you can find that cat boost is outperform and its R square values come to 0.9. Okay. So that is the improvement when you apply the transformation in the data set. Now class, one more important thing, you can also use multiple methods. Let's suppose you need transformation, normalization, outlier. So just pass the function and use the variable. So you can apply 2-3 technique in the same function. Now it's just a matter of changing the parameter. That technique will automatically apply to the data set. So there is no more novelty or research in model building. You need to choose the domain and generate the data set accordingly. Okay. Now next, PCA. PCA is principal component analysis that will be used to uh, reduce the features. Earlier, we are working with images, so that consists of 10,000 features. Okay, number of columns, 10,000 features. That is a huge data set. Okay, now PCA will do reduce these features and just presenting 3 or 5 columns. Means it is just a picture that will convert all the merge all the features in the 4 5 columns only. So that 4 columns are helpful in building the model, because you cannot build a model for 10,000 features. No model will able to handle 10,000 features. So you need to apply PCA. There is no other option than PCA. Okay. Uh, any Python library that select feature from data set using various evolutionary algorithm is generated. Yes. Ravindra, there are a lot of, if you go to the scikit library, learn library website, so there is a section for feature selection. Okay. So one of the topic is over there is genetic algorithm. Also, it uses a recursive method that select the features for you, and that give you the only those features that are relevant to you. And just give me 5 4 minutes. I am also covering the feature selection and feature importance. uh, out out clear out It is not out clear, it is outlier. Okay. So now this is the result after applying the PCA. Okay. Now class, if I want to apply transformation and PCA simultaneously, then you need to do just copy and just paste. Means till now PCA is there and transformation is also there. So I pass parameter for the PCA as well as for the normalization. If you want to apply normalization, so just pass normalization also, and just check which combination perform better for give them better performance for the model. Okay. Now next, so that is the performance of different pre-processing technique applying on the data set. Now next part is applying model, running a single model. Okay. So now some candidate asked for how to run for the different models, different folds. So there is a function with the name create model. So you can pass cat boost. Now how to know how to run the model? If you press shift tab, you will get a list. If you come to the manual part, you will get these are the shortcuts, these are the keywords for the models. Let's suppose if you want to run linear model, so for running a linear model, LR is there. For running a lasso regression, lasso is there. Elastic net, EN is there. Okay. For Bayesian rigid, Bayesian BR is there. Okay. So these are the codes that you can use for the machine learning models. Like for random forest, RF is there. For the decision tree, DT is there. Done. So now I run the model, single model for fold 10. Okay. So this is the result that I got it. Okay, every run for every run. So this is the last part, mean. What is the mean for R square value and what is standard deviation? Okay. So this is a way you can run for n number of folds. Next. So this is the shortcut I already pasted over there. Now next, tuning the model. So basically, tune the model is that what are the different number of optimizer are used. So similarly, if you are using evolutionary algorithm model, so it initially assign some random variables to your model, and it converges in the minimization or in the maximization. So now if you use the tune model, there is a function tune model, you need to pass the train model. Now this train model is just I created earlier. This is the same model that I created for the cat boost. Okay, this is one of the model with the cat boost is there. So I just created a model. In the 3.2, I want to tune its parameter. So I run for number of iterations for 10. By default, it is 10. You can change up to 50, 100. And now, which uh, objective function I need to minimize? So let's suppose I need to use a mean absolute error. I can also use RMSC. I can also use R square value. Okay. So if I run the code, after that, you will find the mean is 0.3998. Earlier it was 0.37. So there is an increment of 0.02 after tuning the model. Okay. Next, so I build the model. The next step is to save the model. So save model, it is a function name. You need to give the model, just that the model that we created earlier, and this is the file name the model will create. So now saving the model, it will save in a file. It will save in a file. Now you can share this file to anyone. Let's suppose you build a model and you mailed me. Okay, so I got the model in a file. So there is no need to retrain the model. Okay, so saving the model is very important. Okay, so save the model. Now it will, you can share this model also. So I save the model in a file with the name cat boost model. If you go to the local, you will find a pickle file. The file extension is pickle, PKL. The cat boost model.pkl file is there. Okay, so that file that contain the parameters, optimized parameter, and you can share that model. Ravinder, you can also pass. Yes, you can compare the fold for different models. The model that we created earlier using compare models. So you can pass the fold over there. Okay. So we saw already saved the model. Now next, now how to use that save model. So there is a function with the name load model. Now that is the file name that I already stored. You may get this file from your friend, or let's suppose I train the model and I send to you, and you need to pass the file name without PKL. So when I load the model, so this is my model name that I can use for the prediction of the new data set. Okay, so what is the use of using the save model? We need to make it available for the prediction of new data set. Okay, now we are give you the demo how to use for the new data set. So I use the Boston data set again. So that is the data, because right now I don't have the other data set for the comparison. So I will took some data from the Boston data set itself. So now I select some data. So data.iloc. So this is the variable data that I just read the Boston data set in this variable data. Okay. After that, ILOC, so :10, it will select you the top 10 lines in the data set. If I print the data set, I will get like this from 0 to 9. So this is a data set I will use for the prediction of new data set using the model that I just recently loaded. Now make the prediction. So there is a function with the name predict model. This is just the model name that I loaded through the file name, and data set is the new data set. So this is the data set that I just read. So if I used the prediction, so just run the model, you will find this. So you will find one column in the end with the name label. So this value is generated by my trained model. Okay. So basically this is the same data set, means 24 is actual value. My model predicted 22 value. Actual value is 21.6. Predicted value is 22.96. So now this value is very almost similar, because the model is trained on the same data set and predicting on the same data set. So it is obvious that it will give the good accuracy. Okay, but if you want to uh, make the prediction on the new data set, all the column name must be the same. Okay, otherwise it will give you the error. Done. Now these are some evaluation parameter that we are going to calculate on actual and predicted. So that is my I am just plotting and save the file. So this is the plot. Okay, that is known as scatter plot. Now I want to save the result to a CSV file. So new prediction.csv, that is an inbuilt function, and you need to just pass the file name. So you will get all this table, this table, and store in a file. Okay. Next, now there are other plot method that I already covered in the upper section. So we are going to pass the different parameters, it will generate different plots for us. Okay. Now this is a residual plot. This is my scatter plot. This is my distance plot. Now this is my learning curve. This is my cross validation curve. This is my main fold curve. So there are different plots, and these are the best hyper parameters that I use for my plotting by building the model. Now that is the important thing about feature importance. So class, feature importance is that, okay, let's suppose we have 1,000 features. How to choose which top features are useful for building the model that give the same performance as we are using 1,000 features. Okay, so let's suppose from the 1,000 you choose only 20 parameters. So that is also known as dimension reduction. Okay, earlier you are using 1,000 columns. Now you are using only 20 columns. So that is known as dimension reduction. And that is one of the important pre-processing step for the data set. Okay. So now class, I trained in this feature importance, I trained different models and I plot the feature. Okay. The very first is cat boost. Okay. So I created a model cat boost and I plot the feature. When I train this model, so component 1, component 2, and component 3. Okay, so these are the top 3 important features. Okay, now next, I trained ET model. Now, I choose these model list from the top performing models. Okay, when I compare the models with the different environment, ET, CAS boot, RF, Light GM, GBR, KNN. So I train each and every model and I plot the features. Okay, because every model will give you the different feature importance. Okay, so you can use ensemble method to get which model give the which are the important features. Okay, so similarly, I created ET model. Next, I created Light GM model. Okay, so similarly, you will get the feature name. Okay, so similarly, this is a thing that will give you hands-on practice how to build all the machine learning models with different evaluation matrices in a quick time. Okay, now the last important point is that there are 2 important resources for to learn and explore the regression at your own. So these are the 2 tutorials. And finally, if you want to deploy on AWS services, so that is the manual. So class, I think you are understanding something. Please write your response in the chat. Do you like this or not? Or you can also write the question.
We have started receiving responses, sir. Yes, people are definitely liking this session. Participants, you can also write your queries in the chat section if you want to know something, if you want to ask something. I can see number of appreciation messages, sir.
Okay, now it is done for the regression. So there are 2 more quick sessions on the classification and clustering. So let's start them. So just give me 1 minute.
Sure, sir. Take your time.
Okay, now let's start for the classification. 90% code is similar to the regression. Okay, there is only minor corrections. So I will handle only that part only. Uh, could we upload our own data set in PyCaret? No. Rizwan, basically, that is the develop. If you want to upload your data set to the PyCaret, then you need to contact to the developer also. Okay, if they allow, then you cannot manually upload the Py to the PyCaret here. Okay, so let's start for the classification. So this is some manual. So I request all of you, please, this is a new library that just come recently in, I think 2-3 year back. So there are a lot of development, more development is there, but 90% will same, only 10% of you corrections they release in the 2 or 3 months. So I'm requesting all of you, because I just covered the 60 to 70%. There are still 30% more that you need to learn yourself. Okay, so these are the two important links you need to explore over there. This is a small manual how to install the PyCaret package, and this is the thing that we are going to learn. Let's start. So very first step, you know very well, data loading is there. So this time we are using the data set diabetes. Okay, so diabetes, this is the sample data set. Okay, so it will show the top 5 rows for the diabetes data set, and the last column is of class variable. So you clearly see that this is a binary classification data set. Okay, now next, get the shape. So it is a 768 number of rows, 9 columns are there. The very first step, to remove the duplicates. So this is step number 1, loading the data set. Next, 1.2, setting the parameters. So set a function. Now this time we are importing the library pycaret.classification, and all the function are imported. So set a function is there. It required only two type of variables: diabetes df and class variable. So class variable means is the target column. Target column means this is the target column. Okay, now somebody asked how to define the k fold for all the variables. Okay, so just press shift tab. So there is a parameter like k fold. So we can easily define the number of folds. Yes, the parameter is fold. Let's suppose if somebody asks how to run for 15 folds. So just pass fold equal to 15. Copy, comma fold, fold equal to 15. Okay, so this is the parameter you need to set. Now I run the code. It will show me the parameter that are set for by default. After that, I run the model compare model. Okay, now these are the some uh, models that run for classifications. So rigid classifier, linear discriminant analysis. Now you know very well if for the binary classification we need, there are few parameters like sensitivity, specificity, precision, recall, f1, kappa, and accuracy. Okay, so these are some parameters on which all the models are run. So nearly there are, I think, kitne hain? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13, 13, 14, 15. 15 models are compared. Okay, so now the topmost model, rigid classifier is the best performer for diabetes dataset. Its accuracy is 76%. Okay, next, plot the best model. So now there are a few parameters that are different in plotting. Very first is AUC. So everybody knows is AUC is under area under the curve. So if you plot the best model, the curve that is near to 1, that will consider as the best model. Okay. So in this model, we are just train a LR model separately, and the plotting I just pass LR model and plot AUC. So let's suppose this is my recall curve. So we need to just pass PR. Next is confusion matrix. So class, this is the important parameter for binary classification. You need to just pass confusion matrix, confusion underscore matrix. It will plot the confusion matrix for you. Similarly, this is the plot for error, class wise error. Same class report. So you need to explore these parameters. What is the importance of class report? Okay. Next, boundary. Okay, what data point is lies over there. This is a learning plot. Okay, now this is the feature importance. So class, I train a model and plot features. So that parameter, that model, if you're plotting the features, it will give you the features in their increasing order, decreasing order. Okay, that is the most important. Decreasing order is there. Okay, so now if I want to plot all the features, because there are 14 features, I think they're over there. So you need to pass feature underscore all. So that will show you all the features. Okay, so that is a basic part about classification. So if you have any question or query, you may ask. Okay, let's move forward. Now this is the same part that I use for the regression. Okay, applied different normalization pre-processing technique in the data set, and we are comparing the performance. So normalization true, normalization method is Z-score. So you will find cat boost again perform very well. Similarly, we want to apply feature selection. So just make it true and pass the parameter 0.8. Similarly, outlier removal. So this is outlier removal, transformation, and PCA. Okay, so class, this is the same way that we apply the pre-processing technique for regression. So we can apply for the classification also. Okay, now this is the advanced part 2. This is the same thing that I covered in the regression. Okay, we train a single model, we tune the model, we load the different prediction, we save the model, we generate ROC curve, precision, recall, library. The same thing is there. You can easily go through at your own. Okay. Now, finally, this is the link if you want to deploy your model. A deployment means you build a model and you want to make it service, web service. Okay. The other person can use that your prediction model. So that is a deployment. Okay. So these are self-learning resources. So you can go through and try to learn more things. It is just a matter of 2 days only. Okay. So now this is the second part for regression, classification, sorry. And now I want to cover the third part, clustering. So screen is visible.
Yes, sir, it's visible, sir.
Okay, clustering is there, na?
Yeah.
Now, one more question is from Welltech Chennai EC. How can I modify the same for the image data set? Ma'am, first you need to extract the feature for the images. You need to create a matrix. Okay. Then only you can apply this PyCaret package. Okay. Image features are must be there. Okay. Now let's start. So again, everybody knows k-mean, sorry, clustering. Clustering is an unsupervised learning, means there is no column, there is no labeled column is there. Okay, so let's run the code. So this is the same thing. I using the version 2.2.1. I load the data set. Index give me all the data set that are available. Now for this data set, I use the jewelry data set. Okay, so there are four columns: age, income, spending score, and savings. Okay, so these are the four columns that I use that consist for the jewelry. So now we want apply clustering. Okay, so next is define the shape. So that consists of 505 rows and four columns are there. Now very first step is remove the duplicates. So dot drop duplicates will remove the duplicates automatically. Now next is parameter setting for clustering. So setup function is there. We need to just pass the data set that we just recently read. Okay, so done. Next part. So come to 3.1.3, building k-mean clustering algorithm. So k-mean is the most commonly used clustering algorithm. So we need to just create a function. We call a function create model. That is a k-mean. If you want, there now. If you go to this table, you will find most of the clustering algorithm are already used or applied. If you want to apply affinity propagation, you need to use AP. If you want to use density, dbscan, so dbscan is there. If you want to use optic clustering, optics, you need to pass optics. Okay, so now I want to build a k-mean clustering. So here we need to define the number of clusters. If you press shift tab, okay, so you will find other parameter also there. Okay, now these are the clustering algorithms. Now if you go explore these each and every parameter, so you need to explore more. Okay, so I run for 4 clusters. Okay, because in the k-mean clustering we manually define the number of cluster required. Okay, now so there is a parameter, let's suppose in the regression, so there are evaluation parameter name with uh, correlation, r square, different error are there. And in the clustering, in the classification, we have sensitivity, specificity, precision, recall. But in the k-mean, there is a parameter known as Silhothi score. Okay, that is 0.72. Okay, so this is one of the evaluation parameter, just similar to the correlation r squared. Okay, so Silhothi score we need to maximize it. So right now it is 0.72. Now next we are apply some different pre-processing technique. So this, there might be possibility this score may increase. Okay. Next, so this is the simplest way to build a k-mean clustering algorithm. Next step, we build a clustering algorithm means we build a model. Okay. Now assign the label to the data set. Assign the label means which data points come to which cluster. So there is a function with the name assign underscore model. We need to just pass the train model. So that is a model that we just recently trained, k-mean clustering model. So this is the model. This is a variable k-mean clustering model. So you need to just call a function with the name assign model, pass the train model. So it will label the each and every column with the cluster number. Okay. Next, we want to save the result to a CSV file. So kmean.df, that is a variable name that just recently used, dot to CSV. So all this table will automatically save to a file. Okay. Now next, plot the clustering. So there is a model, there is a function with the name plot underscore model. We just need to pass the train model. So if we plot the clustering, so this is the data point that are plot in 2D. We created 4 clusters. So cluster 0 to cluster 3, and these are the data points. Basically, you will find these orange part is not near to these purple color points. This is here because in the 2D we can the data points are overlap. Okay. Now just we want to see in the next plot okay, how to visualize in the 3D. Now save the train model. So this is a train model that we save. We can save the train model to a file. This is the same thing just we did in the regression. Now load the model. So load underscore model is there. Now let's make the prediction for the new data set. So we again load the Julie data set. We took 10 records from that data set. Okay. Now we want to make the prediction on this data set using our loaded model. Okay. So there is a function with the name predict model. This is our train model that we loaded from the file. Data set is just new data set. And when we run the code, it will label the new data set. Means this row will belong to cluster 2. This row will belong to cluster 2. This row is belong to cluster 0. Okay. So clustering prediction in the clustering is also similar to making the prediction in the regression and classification. So now we want to save the results. So these are the different plots. The most important plot is now run for the 2D plot. Okay, now 2D plot is there. Okay, now run. Now there's a function with the name evaluate model, evaluate underscore model. So you need to just pass the train model. So evaluate model will give you 5 parameters. So number one is a 2D plot. Second parameter is cluster TSNS. Yani ki if you want to plot, if you want to visualize in the 3D. So now it is executing. It will take some time. Yes. So hope everybody is able to see. So now this is a 3D plot. It will plot all the data points in a 3D. So class, you can clearly see that all the data are almost overlap, but they are defined they are distinguished, they are plot differently in different dimensions. Okay. So now next parameter is elbow plot. Class, elbow plot is the one of the most important plot, and that help you to find the appropriate number of cluster that you need to use in your in the clustering algorithm. So class 3. So it is just a elbow. जैसे हमारी elbow होती है ना. So this is a elbow plot. So जहाँ पे there is a more turn is there, then let's suppose in this example, the elbow is cut at 3, means 3 number of clusters are efficient for this data set. So if somebody asks how to find the good number of clusters for the data set, so you need to plot elbow plot. Okay, this is one of the technique. So means 3 number of clusters are suitable for this data set. Next, Shitholi, it is not executing over here. Distance distribution. So these 2 parameters are not able to calculate. So this is the distribution plot. Okay, how many counts are for each and every clusters? How many data points lie in different clusters? Now, next, if you want to plot individually, so plot model is there, plot cluster, plot TSNE, 3D plot. Next, elbow plot. So these are the way you can individually plot the models. So now recently it is not able to calculate the Shitholi plot. That's why it is giving error. And similarly, distribution plot is there. Now, this is a distribution plot against one of the feature, that is income. Okay. So distance plot भी error देगा है. So that is the basic part about clustering. And that is the next part is applying data pre-processing. Now, similarly, data pre-processing means applying normalization, transformation, and you need to just evaluate, just consider the Sitholi score. So now, if you apply the normalization part, you will find Sitholi score is increased to 0.75. Now, again, apply transformation part, its score is increasing to 0.76. Okay. Now you can apply both the things. If you want to apply transformation as well as normalization, you will see this score is reduced to 0.74. Okay. Apply PCA, its score is again dropped to 0.72. Okay. So this is the way you can apply different uh, pre-processing technique and just check what is will be the effect on the model performance. Now, this is the last part. If you want to apply different clustering techniques, like suppose we want to run, we want to execute agglomerative. Okay. Agglomerative, that is also known as hierarchical clustering. So just you need to pass in the create model, you need to pass H cluster. And you need to give the number of clusters. Okay. So this is the only single change. This agglomerative class model will be built. So this is the performance. Now this is the again now next part is model building is there, saving evaluation. Next is DB scan. So just you need to pass the variable DB scan, create model DB scan. Now, one more important thing about DB scan algorithm is that it is not required number of clusters. It automatically find the number of clusters, because that is the inbuilt property of DB scan, because it is based on the density. Where the density is higher, it will create that number of models. It will not find the distance. Okay. If you want to more learn about DB scan, just you can explore YouTube or any other resources. So that will explain you in the detail what is the mathematics behind DB scan. Okay. So now one more important thing, when we run the DB scan for this data set, it is not able to find the clusters. It gives you the -1. Okay. So if any model will not able to cluster the data set, it will give you the cluster -1s. Means it is your understanding it will not able to find, it will not able to create the clusters. Okay. So these are the only two important things. If you want to save the result, you can use .csv file. Okay. Now this is the reference manual. So class, I am done. So hope you enjoy the session.
Really
so if you have any
marvelous
question,
session,
Theory, you
sir.
may ask.
Session was really marvelous, sir. Participants, you can ask your queries in the chat section. I can see it's numerous appreciation messages, sir. I need not to say anything. You can read in the chat window.
Ravinder, basically, there is no need to tell ki you are using the machine learning model using PyCaret, because nobody is asking ki how you implemented the model, but everybody want to know ki which algorithm you are using. Okay, so that can be considered for your research paper. DB scan importance over other model. They are just see that there are different clustering algorithms. DB scan may or may not work for every data set. Okay, so the main advantage of DB scan is that when you have a huge amount of data, let's suppose you want to cluster 20 lakhs of data, then only DB scan will work.
Any other query participants? You can write in the chat window. If you don't have any query, you can write your feedback also. You can write your feedback about this session. So this is the most usual comment. As usual, Rana ji is superb session. Everybody is aware of your sessions. Really, it was a wonderful session. You handled the session so beautifully, sir, that it was so practically oriented that most of the theoretical concepts were means coded by you, that to live. So this was really wonderful, sir. As you can see in the chat section also, excellent and wonderful session. And please send the link. We have already shared the YouTube link also. So my dear participants, all the sessions of this FDP were live on YouTube. So anytime you can refer to these lectures, to these sessions on YouTube also. Thank you very much, sir. Thank you for sparing your valuable time.
Thank you, Arun sir.
And in future also, we'll be in touch with you. We will bother you once again. And that session may be specifically for our students, so that because we are running BTech in AI and ML, so what I feel is that if you are ready to take one session of our specialized students that they have who have taken admission in BTech in AI and ML specifically, so we'll try to hold one session for those guys only.
Okay, no issues, no issues. I will take.
Yeah, thank you so much, sir. Thank you very much for sparing your valuable time, and thank you all the participants for your patient listening. And one more thing, sir, let me tell you, along with all the participants, that this FDP is running in parallel to many of the FDPs that are conducted by in under the flagship of Atal FDPs. Even then, we are having every day we are having more than 100 participants in each of our sessions, sir. And that too are listening to each and every speaker very sincerely, very patiently, which was also evident from the questions they have asked.
Sir, the main thanks to all your organizing team. You invited all the speakers, and it is your great efforts.
Sir, the guiding force behind this is Dr. Paramanand Aste. He is so motivated, he is so oriented, focused person that he always motivates us to contact people like you, so that all our faculty as well as our PhD scholars and most of the participants who are from outside organizations, we received participation from almost 70 universities, sir, from India, as well as from some Malaysian universities and from some Nigerian universities also. So he's very, very focused person. He always motivates us that keep doing such kind of FDPs. So we will be in touch with you once again, sir. Next year, or we will be doing the third version of this FDP. So thank you, sir. Thank you so much.
Thank
Thank
you,
you all
thank you,
the
thank you. Thanks a
participants.
lot.
And we will mail your certificate to you, sir, by tomorrow evening, sir.
No issues, no issues.
Yeah, yeah. Thank you so
Okay.
much. Bye
Thank
bye,
you,
sir.
Arun sir.
Welcome, sir. Welcome. Bye bye, sir. Have a great day, sir.
Same to you.
Thank you, all the participants.